If it is a positive association, it went up from left to right. If it was negative, down from left to right. No association, you could not draw a trend line. Okay. I got to sit down and teach this one because it's graphing, and my points are never right when I graph them up there. So, okay. So today's about constructing scatter plots. So Chromebooks need to be shut so you're not distracted. Okay, so it says Jared's basketball team Jared's basketball team stood at various distances from the basketball hoop and counted the number of baskets they were able to make in 30 seconds. Use the data in the table below to make a scatter plot and then answer the questions that follow. So this horizontal axis right here, what axis is that? The x-axis. And this one is the y-axis. Now, when you're given a table like this, which one of these, the distance or the baskets, are the x? The distance. On a table, the x is always first, the y is always second. Okay, and it even tells you down here, it's already labeled distance from hoop, baskets made. Because when you all go to Algebra 1 next year, they won't already have them drawn for you. You'll have to draw them and label them yourself. Okay. All right, so it says use the data below or in the table to make the scatter plot, and then we'll answer the questions. So the first point that I'm going to graph is 15 feet and 2 baskets made. So I'm going to go to 15 feet, and then I'm going to go to 2 baskets. Okay, the next one is 45 feet and 2 baskets. So I'll go to 45 feet and then 2 baskets. Yes, Taryn? You just plot it on top of it. It's just the same spot. Okay, the next one is 30 feet and 5 baskets. So 30 feet and then 5 baskets. And then 15 feet and 9 baskets. So 15 feet and then all the way up to 9. All right, I'm going to let you all keep going and plot the rest of them. And I'm going to plot the rest of mine too, but. Shh. Are there any questions about how to graph the points or how to know which one's X and Y? Okay, so the first question that it asks you about that, describe the type of association seen in the scatter plot. So is this positive, negative, or none? Karen? This is negative. I know I've got this one little outlier here, but the majority of the data is going down from left to right. Down from left to right. So that's a negative association. All right, and then like I was just saying, are there any points that don't fit the overall trend of the data? What, Trevor? This one does not fit the overall trend of that data because it's out there. It's an outlier. It lies out of the rest of the data. So there's the rest of the data. This one's kind of just out on its own. So that's the point, like Trevor said, 15, 2. And then we would just say something like it lies outside of the rest of the data. All right, so now it's kind of asking us to look at it and describe any unique things that you notice about that graph. So anything that's kind of weird about that graph. Sims? What?
What?
That he only... Okay, well, that's awesome for him. That's not... I'm talking about the data as a whole. Is there anything like super unique about it? Because there is a... There's a gap. Where is there a gap at? Yeah, like nobody made any shots from 20 and 25 feet. So like right here, like 20 and 25 feet, nobody made any shots in there. So that's unique. And you could also say something like 15 feet and below, they made more shots, but then they made less shots from 30 and 45 feet, 30 to 45 feet. You could say no one shot between 20 and 25 feet from the goal, something along those lines where you're talking about this gap. So I could say no one shot any baskets at 20 and 25 feet, and that left a gap. Something along those lines where you're just talking about that empty space in between. Okay, and the next part, number 4 says, use the scatter plot to label each statement as true or false. So part A says, as the distance from the hoop increases, so as the distance increases, the made baskets decrease. So as the distance increases, the baskets made decrease. Is that true or false? That's true. So the farther away from the goal they are, the less baskets they make. Because look, closer up here, they were making 10, 9, 8 shots, but the farther away it gets, the less baskets they're making. So that is true. Okay, and then B, as the distance from the hoop decreases, so if I start over here, as the distance from the hoop decreases, the number of baskets made increase. That's also true. And one thing that we talked about last week when we were talking about associations, if it was a positive association, then both of them would be increasing or both of them would be decreasing. But with a negative association, one of them is increasing and one of them is decreasing. It doesn't say which one has to increase first or increase second, but they have to either increase and decrease to be negative or increase to be positive. Yes, Taryn? Yes. Yes. So that would also be a positive association, though, because they're both going in the same direction. Okay, so it says scatter plots may include points known as outliers. So that's what we were talking about up at the top there with that outlier point. And may display clusters of points as described below. So clusters are like where that gap was in there and they were clustered together in one spot and clustered together in a second spot. And that outlier is that one that lies out of the majority of the data. So it says a point that does not fit the overall pattern or trend of a scatter plot is known as an outlier. And I always remember outlier, it lies out of the data. All right, and then it asks which player, so the one above, which player represented the outlier, which we already said up here, it was 15-2. So look in your table, which person was 15 feet and made 2 shots? Jared. So Jared was my outlier. And if you're like, how are you knowing that? Right here at the top, Jared was 15 feet and only made 2 baskets, which was this one right here, that one that lied out of the data. That was Jared. If it was real life, it would say Blake, but
Yeah.
you weren't even paying attention.
I'm actually kind of
Oh, okay. All right, and then the clustering. Shh. The clustering is when there are distinct or separate groups of points. Okay, so like I said, like we saw in that scatter plot above, there were some that were clustered in that closer distance, and then they were clustered together in the farther distances. So it says, why do you think the clustering occurred in the scatter plot above? Well, Taryn, what do you think? Okay, that works. Could say something about that is they didn't shoot in that middle part, that 20 to 25, so that's why the rest are clustered below 15 and below, or 20 or 30 and above, because it started at 30. All right, what do you think, Lucas? Because of the distance. Yes, Simmy's.
She didn't go to office. She just purposely increased her Jordans.
Okay. All right, so I think personally that the data clustered together, because if you're only 15 feet from the basket, aren't you going to make a lot more shots than being 30 feet away from the basket? So, why do you think the clustering occurred? And I'm going to put the first four people stood 15 feet and closer. And then the rest stood 30 feet or more away. So something along that line where you're talking about that the majority of the shots were made 15 feet and closer and the rest were made 30 or more. Or you could say nobody shot at the 20 to 25, so that's why the other ones were clustered below 15 feet and above 30 feet. Something along those lines where you're talking about that distance. All right, we're going to flip it over, and I want you to go ahead and graph your data for that graph that they gave us. So if you look at it, it says the population is in thousands. So like the first one is 76,000. And then the number of elementary schools, I know that they don't have a 76 on here. But where does 76 come? In between, about halfway between 70 and 80, because 75 is halfway between 70 and 80. So 76 is about halfway. And then it says at 19. Well, they don't have a 19 over here. They only have an 18 and a 21. So like 18 and 21, it's going to be just a little bit more than 18. So when I go up here, it's about halfway and it's about right here. So yes, I know that they don't have the most perfect little lines like the other one did, but you can still do it. And then like 60,000 and 17. So they've got a 60 on here for 60,000, but they don't have a 17. Well, 17 is almost to 18. So that's where I'm going to put it. All right, so I'm going to give you a chance to put the rest of those on there. This is why I don't like to graph up there, because I never get these anywhere close. Yeah. All right. So it should look something like that. Yeah? See? No?
Yeah.
See. Okay. All right. So describe any association that you can make from the graph. What association is this? Positive. It's a positive association because it's increasing from left to right. Is there any outliers? What?
2018.
The 2018, the 20,018. And the reason it's an outlier is because it lies out of the rest of the data. I don't know why they make us explain that. Lies out of the rest of the data. All right, does this one have any clustering? Is there a big gap? Is there a big gap anywhere and there's a big cluster of stuff? No. No, this one does not have any clustering. The reason it doesn't have any clustering is because there's not a big gap anywhere in the data. All right, and then the last one here. The table below shows the number of days since several students added money to their lunch accounts and balance of the lunch account. Now, when they give you a horizontal table like this, which one's the X and which one's the Y? Top is X, second one's Y. So I know it's 16 and like 5.25. So we're probably gonna have a mental breakdown, some of us. So obviously 16's right here. 5.25 is a little bit more than 5. So 5's like right in the middle. So it's somewhere like right there. It doesn't have to be perfectly perfect. You just don't want to put it on the 6 or put it on the 4 because it's not 6 or 4. It just needs to go somewhere in between there. Yeah. I don't know. All right, shh. Come on, let's finish this. We can talk about that later. Shh. 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 Hush. All right. Everybody get that for the graph? Something along those lines? Shh. Semis, did you get that?
Yeah.
Okay. So, what association do you see here?
Negative.
We see a negative association because it's decreasing from left to right. Does this one have any outliers, like any ones that lie really far out? No, this one does not have any outliers. None lie out of the data. All right, shh. All right, does this graph have clustering? Yes. Okay, it does have clustering. And there's two things that you could talk about that clustering. Does anybody want to tell me what they think? All right, Taryn. Not 8 and 12. 6 and 12, because what could, if you had to base yourself on what this problem's talking about, what could you estimate from days 6 to 12? Karen? No one subtract anything because it's negative. Okay, so you could say, yes, no one used any money days 6. Well, it's actually day 5. Actually, day 5. Days 5 through 13. Okay, you could say they only spent money on days 1 through 4 and 14 through 20. You could say something like that. Or you could say they didn't spend any money on days 5 through 13. So either one of those would work. All right, before we go to the homework, one thing I want us to practice is drawing trend lines. Franklin. Hey, we're going to draw a trend line here. So reminder, a trend line, it just tries to hit some data. So if I'm going to draw a trend line here, I would do something like that. Okay? All right, I want you to draw a trend line up here. A trend line, a straight line. So look what I did down here. A straight line that tried to hit some data. Okay, so draw a straight line on number 5 that tries to hit some data. Shh. I know it doesn't ask for it, but we're going to need this skill for tomorrow. It has to go positive because our association's positive. It has to go from the left side to the right side following the association. So like this one, I would have done something along that line. Okay? Yeah, like. Okay, so that's what we're going to work on tomorrow. Tomorrow we're going to work on trend lines. And scatter plots are like one of the most applicable things that you could use like in a real life job. You could get some data, you could draw a trend line, and you can use a trend line to make predictions about things. So like, for example, COVID cases in schools. I'm sure they used a scatter plot. I'm sure they drew a trend line to make a prediction of how fast it was going to spread in schools, or what they predicted the amount of kids that would be out on this date. So what we're going to do tomorrow is we're going to draw a trend line, and then we're going to say, okay, well, I think I'm going to use this point and this point right here, and then I'm going to find my slope between those 2 points, and then I'm going to find my y-intercept. So we're going back to something that we've already done, but that gives you an equation that you can use to make predictions about that trend line, about that scatter plot. Yep. Not on the final, no, but you do have a quiz on this Thursday. Okay. So I'm going to go ahead and pass out the homework worksheet.